Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today what we're going to do is we're going to continue testing this Class D amplifier, the one that's called a 300 watt plus 300 watt. It's not that, we know that. As a matter of fact, I did a video some time ago. I did a couple videos on this, by the way, but I did one video, how much power can it really put out? And in that video I showed continuous power and, you know, with no fans or anything, and then how long it could put out that power before it thermally shut down. And so, I kind of forget exactly all the things I did, but I ran it for a while, but if I did a certain power level, after, I think it was 4 or 5 minutes, it would shut down. So I put a fan on it, and I showed how you could get even more power. I want to say it was like 120 watts into 4 ohms, I think is what I hit. It's kind of what I remember. So 120 watts into 4 ohms, 60 watts into 8 ohms. That's not too bad. For a little amplifier like this, that'd be awesome. That's per channel, right? So that's actually not bad at all. But in this testing we're going to do right now, we're not going to run it that high because I'm not going to use a fan. I think what I'm going to do is what I plan to do is specify this thing the way it sits without adding and changing, modifying. And then if you guys want me to, I'll do some modifications to this and to lower the noise and also make it run longer without thermally shutting down. Maybe with a fan, maybe without a fan, maybe both ways. Fans obviously are going to help. But I also think I can make it run longer without a fan, just doing a better job at cooling it. So let me know what you guys think about that. But meanwhile, in this video, what I want to do is set this thing up for the Quant Asylum. Now, you may think we already did that. In the previous video, what I did was I tested this guy with the WampTech to make sure everything's working, both channels and everything's working. It was. And I could current control, voltage control with this guy. And it was just real easy. See, arm's length away. And it's amazing how much power you can get out of this old guy. So I did that. And then I have this 600 watt power supply back here, right? So I took that guy and I powered it up with this volt box. And that way I could adjust the voltage slowly, watch it come on, that kind of thing. So I tested that, made sure that worked, and then I connected the two things together and we tested that and verified both channels, everything's working, turned it, just did smoke test finally, turned it on, and yep, everything worked. So now we are where we are today. So today, I was going to do the Quant Asylum testing, which I could, and I could just jump to that and show you a bunch of test results from that. But I thought, well, if you guys like watching the setup and the preparation, there is some more stuff I need to do. What I need to do is I want to test this thing at different power levels, right? And I want to make sure that the noise and the frequency response, I want to characterize that. I want to know what that is from 1 watt all the way up to, let's say, 100 watts, if we go that high, okay? So I want to find out what those two levels are and find out, because then the Quant Asylum is gonna do a bunch of test levels, however many we want, between those two things. And it'll show us how linear it is between those ranges, how linear it is across frequencies, all that stuff. So we want to really characterize this amplifier and test it out. So that's what we're going to do today. I'm going to use the mixed sig with some probes here, and I'm going to watch the signals and find out how much signal I need to put in from the Quant Asylum. I'm going to hook up the Quant Asylum, and we're going to see how much decibels we can put into it to get say 1 watt out, and then we're going to crank it up and find out what that max power level is and see what the Quant Asylum setting is for that. That way, when I do all these automated testings after that, when I say, okay, test from here to here, I can say test from, say minus 20 dB to say minus 5 dB, something like that, okay? So let's go ahead and find these power levels. We're going to see the THD, and we're also going to see the THD+N on the Quant Asylum software. So as we do this, we'll see both those things, okay? So let's come over to the bench, and now the first thing we're going to have to do is when we come to the bench, I'm going to show you how I'm going to hook up the Quant Asylum to the board, okay? And the next test, when we do just the Quant Asylum testing and we're all ready to go, we want the setup as clean and as pure as we can with only the Quant Asylum hooked up. At that point, I'll disconnect the mix sig, okay? So what we're going to do now is I'm going to bring you over the bench. I'm going to show you. We're going to set it up. We're going to kind of clean up the setup, clean up the configuration from what I had last time, and we're going to set it up for today's testing. All right. So let's come on over and do that part. Hey, and before we do that, one more teaser. I want to give 2 big thumbs up to the 3 folks that sent me a super thanks. YouTube had that super thanks. It's a one-time donation kind of thing. And it's, buy me a cup of coffee kind of thing, buy me a beer, that kind of thing. And so there's 3 people. I mean, I haven't had 3 people in that short time span hit that button. And that was really awesome. So I just want to point it out. And I think I should point out all these things in the future, right? I kind of did last video. I had 1 person over a certain time period. But now I had 3. That's pretty awesome. So always broke, LOL. Thank you very much. Appreciate it. And Astro Panos, I think it is Panos. Sorry, don't want to butcher the names, but appreciate it. Thank you very much. And also Zorro Luva. So thank you again. Appreciate that. And so we're going to come over to the bench and we're going to look at the test setup. Okay, let's do it. All right. So here's the board. And I have the input here. I have the oscilloscope. I was looking at the input, so I'm going to disconnect this. And it did have a ground connected to the scope. So we're going to disconnect that. I'm going to lay that right up here. I already disconnected this channel, the differential probe to that. That was this guy up here, this mix sig, in case you're wondering. Okay, so I had that guy. And there's mix sig right there I had hooked up. So I still have 1 mix sig differential probe. I'm going to leave that on there. That, by the way, is the last capture I had. This was at 13 kilohertz. You can see that right up here probably. So I had both differential probes on 1 channel, so they're overlapping. And the green was the input. And this one right here is actually something a new connection. It's this current probe. Now, since it's a current probe connected up here, so it's galvanically disconnected. So I think I'll leave that on there just so I can, watch what's happening there. And by the way, that is the ripple at the frequency that we're putting out, which is basically high frequency, right? It's the 13 kilohertz ripple that the amplifier is pulling current, 200 milliamps per division. So that's what that is. Okay. All right. So I still have that diff probe there. I'm just going to leave that for now. Coming over to the Quant Asylum, I've got 4 probes, so I can hook up differentially, okay? I'm only using the positive ends of the clip. So the positive lead, where the signal's coming out, okay, that positive lead is right here, okay? So I'm going to come over here, and I'm going to go to the positive. And I've got both channels shorted together, okay? And then I'm going to leave that there. Okay, now come back over here, and this one that's tied to the negative input, I'm going to take that guy. So this positive one is actually the negative input, okay? So come over here and let's connect that to that input. So that's my differential input, okay? So then what I'll do is I'll just tie these 2 grounds together, okay? Can't do it right now because I'm holding the camera, but I'll come over and tie those. And essentially what that does is these guys are shielded right up to here, and I'm going to end up twisting the wires so they're shielded right up, so they're kind of twisted up here, and then I'll tie the ends together, okay? I'll show you that when I'm done. Coming back here, so that was the output, the signal going into the amplifier. This is the input into the Quant Asylum. So it'll be the output of the amplifier, so plus right here. And by the way, I've already got these leads, the two of them, tied together to the negatives. So this one's a +1, and that will be the negative one. Okay, that'll be the negative coax. So I come over here, and I'm going to come up here, and I'm going to tie this to the positive. So now once I move that differential probe, then I'll have to make sure I have these still on there good. But for now, the first test, I'm just going to leave them on there to make sure the amp is running. You know, sometimes if there is a grounding issue, if something does happen in between test configurations, you could be scratching your head wondering what the heck's going on. So that's why I want to do that, so I can watch the signal coming out. And also, I want to make sure that my maximum amplitude, okay, I'm taking these ground signals over this way. I think I'm going to go up here and twist these wires around, and I'll come back and show you that for both, you know, connections, okay? But yeah, so I want to make sure that when whatever signal this thing's putting out, that I'm telling this thing to put out a certain decibel level. I want to make sure the maximum dB out here gives me my maximum voltage here without clipping. So that's one of the reasons I'm going to do this. So, okay. All right, guys. So I want to show you the twisted pairs. So I have the things twisted, and the ground's just kind of hanging out here. That's the shielding, right? So we just have shielding up to here, and I could probably terminate the shields to some common ground, but I'm not going to. I'm just going to leave them right there for now. And then I've got the two connections, my differential connections to the input, and both channels are being powered again. And then over here I have the differential inputs, and I'm going to try to keep that from touching. You know what I'm going to do is I'm going to move this resistor here. It's been kind of bugging me. I'm going to move that over here so it's out of the way. So the wire, my power wire here is not, and then that way it's easier to set up these guys. So I'm going to move over, whoops. I'm going to move these to come in from this direction, and I might just put a screwdriver down there to kind of hold them in place. Okay. I'm going to bring them up to the board, click them up like that. Okay. And so I'm going to hook those guys back up, but I think that's a lot cleaner. That way my cables are nice and clean. These cables over here, and meanwhile the power cable is also twisted nice to go up to the power supply. So everything, and I do have the differential probes, which those are the things I'll disconnect for the when we do the for real Quant Asylum testing. Okay, that way that's the only thing connected. But you know what, I'm going to leave this current probe because I want to watch the noise on the input. Okay, so let me fix this right here. All right, guys, so this is the way it kind of ended up. So I've got the two reds there, the differential readings on the output. I got the ground sitting over here, and there's just plastic on the corner of this board. So I'm just going to prop those against that to make sure that they stay there, and that's the way it's going to be. So over on the Quant Asylum, that's the connections. We got our plus and minus for our differential on both sides. The right channels we're not using, so they're plugged on this side. Those are shorted for the output. The input are just open. And yeah, that's the way it's going to be. Okay, so let me go get my laptop and let's get going. Okay, guys, so we're getting ready to turn on power, right? We're all getting excited. Okay, first I want to show you what I'm looking right now. I've got the Quant Asylum hooked up, okay? And look on the screen here. So on the screen, you see this signal right here, 10K? That's the signal I'm putting in. And up here it says minus 90.15 dB, so it's way down there. The value is right here, 31.16 microvolts RMS. So very small level, but it's interesting, right? That we actually see a little bit of the signal getting to the output even before we turn on everything. Now also, coming over to the left here, you see this spike? Now that spike, I could take a measurement, but I'll just, do this quick. This is 100 hertz, see down here. So it's 90, 80, 70, 60. So that's 60 hertz. So that 60 hertz is from the AC power. Now it's down like minus 100 dB, so that is so low. It's just interesting, right? It's interesting that, first of all, the noise floor of this instrument is very low. Let's look at it. Look how low the noise floor is. This is 120 dB. I mean, we're seeing some really low noise down here. So we're not seeing much of anything, but we do see these little spikes popping up. I just want to point that out because that just shows you the depth of this instrument. So it has a 24-bit A to D chip in it, or chips, but that gives us this really great depth in the vertical amplitude, which is really awesome for this instrument. So I just want to point that out, how we're starting off, okay? Now let me show you this. If I go to generator right here, and I click on this with my control key holding down on my Mac at least, it comes up, shows me, I put it in 10K, but it's 9.99. Because of the samples and all that stuff, it's probably 999 all the way out there. And amplitude is minus 25. So I'm going to shoot for about 27, I think, just to see what that does. I'm shooting for 1 watt, okay? And then we'll find our max amplitude. But we can calculate it once we look at our gain. And hopefully the gain doesn't change, right? So, okay, let's go ahead and say, all right. Now, if I turn this off, the generator stops. So it's not putting any signal out. It's just all stopped, right? So it's just running. So now we're going to go ahead and turn on power. All right, guys, so I'm going to turn on power. And I want to show you something on the MixSig as well, okay? So I'm going to, because we're going to take that probe off, like I said, once we get all ready to start doing all the testing. And I got my calculator here, so I can do the calculations to figure out how the signal, once we know the gain. Okay, let's just turn this on and you'll see what I'm talking about. All right? Glasses, blast shield. Put that over here. And I'm not too worried right now with the heat of the resistor being, compromised with the not having free airflow, because right now we're not leaving it on long enough to worry about that, or even the amplifier. And I've got plenty of airflow underneath it, so that's not an issue right now either, okay? All right, so got everything going. I'm going to go ahead and hit this power switch. And everything's looking good. Okay, come over here and look on the scope. I mean on the Quant Asylum. And it says we have 5.83 dBs, okay? So 1.9 volts RMS. I'm going to calculate that. And yeah. So here's the THD. It's way down there, 0.05. All right, and then over here on the right, it says gain is 32.84. So I got to remember that, 32.8. And all right, so that's our gain. And you can see our signal. It's right up here. It says 5.83 dB. And over here on the left, you can see 0 to 10. We're somewhere in the middle, so that looks about right. Then look over here. This is interesting. At 20 kilohertz, we got 20 kilohertz. And then we have these little sidebands. These little sidebands are probably this 60 hertz. Look at this 60 hertz. It went up to about minus 50 dB. A little bit higher than that, actually. And then we have all these frequencies. That's going to be 120. That's going to be, because our bridge rectifier is going to give us a 120. Plus, it's a harmonic this. I think that gets double dipped right there. And then we got 180, and then 240, and so on. So all these spikes through here is the our low frequency switcher. Now we got this 600 watt switching power supply, but on the front end of it, it's got the low frequency 60 hertz switcher, right? I'm pretty sure we're gonna have to look inside that. Maybe it has a PFC, but it probably still has a bridge rectifier with the bulk capacitor. I don't know. Anyway, we'll have to take a look. But that's the noise over here. But again, this is really low frequencies, and all of these things are way down here. Here's minus 70 dB. There's one that kind of peaks over that. The rest of them are between minus 70 and minus 80. So very low stuff. Same with these two little sidebands. This second harmonic is sitting here at minus 60. That's why we're going to have 0.04% THD. And it says minus 66 dBs. So that's still pretty low, right? Alrighty, that's what we need to know is that 32.8. I'm going to freeze my mix sig so I can show you that. And yeah, so there you go. Okay, we're set up. Now we got to find our, that's 2 volts is roughly 1 watt. So I think that's a good level for our low level. Now we need to find our high level. So we're going to find our high level, guys. I'm going to show you the mix sig with this guy, so let's look at that. Okay, all right guys, so I have my iPad here, just looking at the signal here. I'm going to show you what I'm looking at here on the screen, and what we have is the yellow signal at the bottom is the output voltage. Okay, it says up in the top corner 11K. It should be like 10K. I don't know if it just didn't capture enough cycles. I'm not sure what happened there, but yeah, anyway, that should be 10K because that's what we're putting out on the Quant Asylum. I think I'm going to change that to 1 kilohertz for the next test, for the higher power test, because I want to make sure we're closer to the middle of the spectrum, you know, the bandwidth, because we're going to check the flatness of the bandwidth. So I want to make sure we're in the flat part when we set the max, okay? So anyway, but I just left it at 10K because I thought it was going to be kind of fun, especially at the low level. But yeah, so anyway, but it could have thrown me off on my gain, right? So maybe at my low level, I'm going to check the gain at 1K before, so I can calculate what it should be at the higher output, and that way I'll know if it's going to be like 32 dB or 33 dB or something like that. All right, so yellow signal. You guys are probably looking at that high frequency stuff riding on top of it, right? So we have our audio signal, the 10 kilohertz, which is basically a carrier wave for that high frequency signal coming off of the Class D amplifier. Now, as it turns out, you can't hear that. It's 450 kilohertz, I believe. I think that's the switching frequency. So yeah, you can't hear 450 kilohertz. So, and it's outside our noise measurements even. So it's not, you know, what we can see there. Now, if there's lower frequency harmonics in there that we, you know, you can't see with your eye, that's the thing that's cool about a spectrum, is that, you know, you can see things that you can't see with your naked eye, right? I mean, looking at time domain at least. Now that blue jazzy looking stuff up at the top, that's the current. See, it even says current, 40 milliamps per division, because I got it set for current. So that's my current probe over here, and it's just looking at the voltage coming to the input of the amplifier, and it looks nasty, right? Once we take up power, we'll probably see some like cyclic, you know, some ripple current there. Probably see it following what the output looks like. But right there, there might be something cyclic there that follows the output. I think there is. But it's covered up so much with these spikes that you're like, wow, what the heck is that? So that's that Class D. Now, I don't like this because that means that the Class D amplifier is pulling current at 450 kilohertz. Each one of those cycles, you can kind of see how those little yellow, you know, that high frequency switching on the yellow, you can see how that lines up with each one of those spikes, right? So every time this Class D is switching, it's yanking current from the power supply way over here, across the street, down the, you know, on the other side of the neighborhood. That's not good. We want it to pull current locally, right next to where the FETs, where the device is switching. That's those 2 bulk capacitors on the board, but they're bulk capacitors. That means that they're good for bulk. They're not good for high frequency. So that's why this board really needs, I don't know, I haven't tried to reverse engineer it, but my last testing, when I was testing for noise and that, I did put some high frequency caps at the input terminals, which helped. So like I said, we're going to do this testing as is, the way it is. And then, like, you know, if you guys leave comments, if you really want me to do that, I can clean this board up, do some things to try to improve the performance without, you know, doubling the cost of the board, right? Anyway, Or we can double, triple the cost of the board if you just really want to see how good you can make it. But I don't think we need to do that. Well, sometimes heat sinking can be expensive. But anyways, I just want to point out these signals. 1 watt output, essentially close to 1 watt. It doesn't look that great. So yeah, we need more local high frequency capacitance on the board. That's what this is telling me. And we'll probably see noise. I mean, this is EMI. This is EMI that's going into this switching power supply. It'd be interesting to look on my power cord over here to see if that stuff carried all the way through the EMI filter of this power supply and all that stuff all the way up into here. So yeah, we don't want that. So anyway, maybe I should do a video on that before I clean it up, just to see how far it went upstream, right? Is that interesting? I'm kind of interested in that. That could be a short video maybe. Anyway, all right, so enough said. But this is important stuff, so I just want to stop and talk about this. So let's go ahead and switch it to 1 kilohertz and find our high level that we're going to test to. All right, so there is our signal. Let's go up here to the generator. I'm going to hold my control key, hit the mouse button, and there we go, 10K. Let's change that to 1K and say OK. Now we have this little peak right here at 1K. Oh, it's running now. Wow, look at that. It is way down here. It's interesting. At higher frequencies, the amplitude went up. Now this is with the power amplifier turned off. So it's down here at the 60 hertz. It's just hanging around. Okay, we got power on. All right, nice. Okay, there's our power. And we got 2.6 dB. Let me chop it down. We want to get close to 2 volts for that 1 watt thing again. I'm just going to try to get so closer than, okay. I want to make sure at 1K we're set up right, okay? So, oh wow, look at that. That's almost exactly 2. Wow, that's awesome. Okay, so let's go see where my generator is set for that. Okay, we got to remember that, minus 27 dB. Boy, that's set. Is that where I had it set before? All right, well anyway, so there we go. Again, look at THD. It's 0.017. I don't know if I pointed out the THD plus a noise. I might have pointed at it and I didn't say anything, but it's 0.16. So it's like 10 times higher with noise. So there you go. That's with all this stuff. There's our power supply, 60 hertz, up around 50 dB. And there we go. All right, so let's go ahead and start cranking this up. I could do 1 step at a time, but I'm just going to come over here and change this from 27. I'm going to change it to like 15, no, to 10, because I know we're going to be closer to 5 or 6 or something like that, at least I think. All right, so hey, I want to show you the mix sig for a moment. See it turn on and off? So that's what's happening, is the generator is taking samples. When you're looking at the Quant Asylum screen, you can see it kind of, change, update, change, update, and that's what's happening. So the signal is going to 0 and popping up. So that is kind of brutal to the amplifier, right? All right, so here we go. We are up here at 14.8 volts RMS. That is actually fairly high. Okay, that's 54 watts. I think let's go a little higher. I'm going to go, okay, there's 18.6 volts RMS. Okay, that's about 110 watts. I think we're going to thermally shut down a little bit, so I think that will probably be a good level. I think we could, yeah, we just shut down. See, that's the thermal shutdown. All right, guys, we thermally shut down, And that's what happens. So we might be able to, I mean, that's 110 watts. And we might be able to run that long enough to do some testing. So what do you guys think? Should I drop it so that it's more what we call continuous power? Because that's not really continuous power. I actually think continuous power is going to be like more like 70 watts. But what do you guys think? This would be more like a longer dynamic range test, not really continuous. It would be kind of cool to be able to test, you know, this higher thing. Now I've also got this box on top of it, so that's not helping things because I don't have free airflow. So I'm going to shift this over. Really what I'm worried about is those capacitors blowing up in my face. So my blast shield, I'm going to adjust this so it's just covering up those bulk capacitors. I don't expect anything to blow up, but when I'm sitting this close to it, looking at the camera, doing all these things, you know, I just don't want to be thinking about what's happening at the board. Normally when I'm testing, I have to have a thermal camera, I'd be probes, I'm looking at what I'm doing, and I'm not going to be surprised as much as when I'm sitting here filming. So anyway, so that's, well, I'm just letting it cool down a minute. We'll be right back, and then we'll take that test measurement again, okay? All right, so we're back here looking at the screen. I'm going to go ahead and turn on power. This is our input signal, so our input signal's just leaking through. Now we have a higher input signal this time, but you know, it's still below 80 dB. 83 dB says up here at the top. That's 66 microvolts, guys. All right, so let's turn on the power again. And did it immediately? Oh, it went into protection because I need to turn off the signal so I don't have that big signal going into it when I turn it on. Okay, turn off that. Okay, now we got 2 red lights on the board. Now let me crank it up, turn it on. Wow, does not like that. That's too much signal. Okay, let's see where we are. We are at -7, so we're going to go to -8. We're going to just go 1 dB down and see if that's enough. Okay? Let's try that again. Turn this off. Maybe it doesn't like to just jump into that big signal. Ah, it did it that time. Okay, so there's 8 dB. I'm going to go ahead and freeze this because I want to just talk about and turn off the power so we don't thermally shut down. Okay, I'm going to shut down power right there. I had to turn it back on so I could capture it on the mix sig. Alright guys, so what we're looking at is up here we got 0.64% THD. Okay, now THD plus noise is the same. What I noticed is as I was creeping up the power, the THD was catching up to the THD plus N. THD plus N went up to 0.6 and then THD caught up. So if you go back and look at that video, watch those two things, I think that's what we were looking at. I need to go back and look at myself, but that's kind of what I remember. All right, so we got 25 dB, 18.6 volts. All right, so that's almost 87 watts. So we're right, you know, we're right up there. And that's where, if we leave it there too long, I think it thermally shuts down. I think that's kind of what I remember. I believe at 70 watts, it will stay on for 5 minutes or something like that. So we need cooling to get this kind of power out. I think we can drop it down to 50 or 60 watts and it'll run continuously. And this is in the 4 ohms that I'm talking about. So, okay, so I just want to point out these two THD right there, 0.64, which is equal to -43 dB, which would be down here. So if you add up all these peaks, it'd be enough energy to have noise floor down in this level, okay? So, so that's our THD plus noise, and right here, and it's the same as it is over there. I mean, they're essentially the same. They're slight. THD plus noise is slightly higher still, but ever so little. Now, when we come over here, I want to point out the 60 hertz. There's, again, 100, 90, 80, 70, 60, okay? And then there's an interesting spike right here. I don't know what this one is because it's like 70 something. So this is a curiosity right here, okay? But this guy over here is 120 hertz and then 180, and so, well, 180 is right here. So I wonder what that guy is. I wonder if that's, anyway, I think this is 120. I think this is 180 because there's 200 right there, that line. So anyway, this stuff down here is from the 60 hertz low frequency switcher that we have. You know, pretty much every power supply has. It's about minus 50 dB right there. And our signal is up here at 25. So it's like 75 dB from signal to noise to that spike. And then these guys are higher. These guys, this is 2 kilohertz. This is 3. And there's 5, and then 7, and then 9. So we have our odd harmonics. And so the top 3, and our third and our fifth harmonic are pretty high, right? And then they start to drop off. So that's pretty interesting. It looked, I could see these creeping up. I have to go back and watch that video as I was creeping up the power over here, like how these things were changing with it. But, and again, I think all this is the power supply noise that's switching into here. It kind of drops down into here. But yeah, I think there's some work we can do. But I think I just want to take a bunch of measurements with the Quant Asylum the next time out. So, all right, guys. So what I want to do is just look at the mixing for just a moment. Talk about it. The yellow one at the bottom is the output, right? And it's saying we have about 18.49. And the blue waveform is our input current. See, now it's sinusoidal. And it looks like it's essentially double the frequency as the yellow one because, you know, it's providing power for both the plus and the negative pulsing, right? So the Class D amp has 2 transistors doing the positive cycle and then 2 doing the bottom cycle. So it essentially looks like double the frequency at the power supply. So yeah, you see that, and then you see the blue furry fuzzy stuff on top. That's the thing where at the input, I think we could clean this up right here. So that's something I'd like to do. Also, this thing needs some better cooling to get the power up. Now for music dynamic power, maybe it's not a big deal, but I think still we could do something, right? So yeah, give me your comments down below what you think, okay? All right, guys, so I can already tell that compared to the ice power, it's not as clean, right? Doesn't look quite as clean. Now, can we clean it up doing some stuff on the board? Yeah, I think we can, but how much? I'm going to do the bank of testing still the way it is, and then the only thing I'm not sure about is the max power, what I should test to, because I would like to say this is steady state. So I think as far as the spec that we write down for this, I can go back to my last video on that and look at that. I'll put that link down below again. I'll also put the link where I first looked at it and I did the Borbede plot just to see the bandwidth and all that stuff. So I'll show those 2 things. Now just to remind you, most testing is done at 1 watt. We don't want to do that. We want to test at 1 watt to begin with and go all the way up. But is there any reason to go lower than 1 watt? Should we go a half watt? I don't know. Let me know what you guys think. I think 1 watt sounds reasonable to me, but I don't know. Maybe there's a good reason to test something lower. So let me know what you guys think. Otherwise, I'm going to go test this in the next video and do all those testing. I don't think I've actually shown you guys all the curves I got from the ice power because I wanted to get it back from my buddy to redo those tests to make sure I had a clean setup. But maybe I'll go ahead and just put out a quick video just showing you what I have so far, so that way you can kind of compare it to what we're going to see from the Quant Asylum, okay? I mean, already the THD+ noise looks a little bit higher, right? So, yeah, it's going to be curious to see how this thing tests out in the next video. All right, so 2 big thumbs up to my patrons as always. You guys can hit that thank you button down below. Appreciate that. It's a one-time way to donate. become a patron for as little as $1 a month, or what else? Oh, there's also Venmo or PayPal or something down below. I forget what it is, but you can also like it, and that's a free way to support the channel. Just like the video, share it, become a subscriber if you haven't done so. That would help a lot. I think about 70% of my viewers are not subscribers, so yeah, really appreciate that. So, all right, guys, thanks for watching, and we'll see you next time.